Can anyone tell me the 3 types of rocks?
Igneous,
sedimentary, and metamorphic.
Great. Make sure you're writing everything that I do. I'm checking my spelling. Does anyone know how they're formed?
there's a couple different processes, mechanical weathering and
Yeah.
with the other.
Great, so let's go over that a bit in detail here. So first we're going to draw our landscape. So I'm actually going to draw a volcano. And often when we're around volcanoes, we often have mountains. Good mountain drawing. And it goes down in a river, and it goes to a lake. Or the ocean here. So I'm just going to draw my water boundary layer. So let's talk about igneous rocks first. So when we learned last class that magma is deep in the ground, and that is molten rock, right? So we just learned that it's liquid. And then when we have a volcano, the magma comes up to the surface and it comes out. And at the surface, this is where it turns into lava. And as the lava cools, then we get igneous rock. So when we have igneous rock, can be formed outside the ground, and we call this extrusive igneous rock. But what happens if the magma comes and say it finds a crack in the ground and then it forms another pocket? It doesn't quite make the surface. We're going to call this intrusive igneous rock. We have extrusive is on the outside, intrusive is still in the earth. So which do you think cools faster, extrusive or intrusive? Extrusive cools faster, yeah. Why do you think this is?
It's exposed to the air.
Yeah. Cool slower. So we're thinking that last class we learned that rocks are made up of grains. So if we're thinking about these grains and crystals and stuff, and as they cool, what do you think happens to them if they are cooling slower? Yes. So let's give us some properties. So when we have igneous rock, more time to form crystals, and they'll actually kind of clump together. So we'll see intergrown crystals. So what happens if it comes up to the earth and it cools much more faster? Do the crystals have time to grow? No, so we'll see more of a glassy texture, or maybe a combination of both. If lava comes up, could we maybe see air bubbles? Can that be trapped inside the rock? Oh, great. We call this vesicular texture. We'll just put air bubbles here so you can remember it later. So these are some characteristics for igneous. So is there a way that igneous rock can make another type of igneous rock? What would happen? questioning faces. Could it become magma again? Yeah. We're gonna call this melting. That's the process that we go on. Can igneous rock become a different kind of rock? Why not, right? So what we have here, so I'm in the way of it. So how do you think mountains are formed?
My rock.
Yeah, by rocks. So we'll get an uplift from other type of rock, come up. Just put here, uplift. So we have the mountain. I'm going to switch colors so you can help identify the different types of rocks. And we have this is my cloud, some rain coming here, and it's beating up the side of the mountain. Maybe we have some wind. Maybe label that. So what would it do to the rock here? Break it down, yeah. We're going to have chunks of sediment that comes down. It's going into our rivers, our oceans. We have erosion, yes? So over time, the sediment comes down. Sorry, I write better from this side, but I know I'm kind of blocking the way. I'll try. And then we have forms a layer. So another over time, and we're talking about thousands of years. We're not talking about days. More sediment comes, pebbles, maybe sand comes off. We'll get another layer. And then many more years, we'll get another layer. And maybe one more. So you guys see how we got some layers of different type of sediment here? I already said that we have time. And what's happening from the top layer to the bottom layer? Yeah, we're getting more pressure. So as we have more time and pressure, and even the water that's here, it's going to squeeze down, squeeze those grains we talked about, and it's going to compact them, and it's going to form sedimentary rock. Okay. So we have compaction, it's compacted, and what can we see here? Yeah.
I've got a question. Isn't that how like diamonds are made?
That, good question. I believe so. Lots of pressure. We'll circle back to that later. Can we see any layers here? So we're going to write that down. It has layers. And the misconception is that layers can form in any direction, but reality is when the soil or dirt sediment comes down, it always goes horizontal. But sometimes when you drive by a mountain, you might see it's at an angle. It's not because it settles that way. That's because it's been uplifted. So it always goes horizontal. We'll write that down. So of these two different rocks, where do you think you would see fossils or shells inside the rock? Igneous, sedimentary? Yeah. So we would get the animal or shell or something would end up being fallen in here, and they would get squished in the inside. So we'll put fossils. Shells, maybe. So I ask you now, can a sedimentary rock become an igneous rock? Sure, yeah.
If it has heat, it could.
So, given lots of heat, will undergo this. And what did we say this process is? Thank you. Melting. Lots of heat. So another thing too is that sedimentary rock can get uplifted again and go through the whole process where it becomes new sedimentary rock. There's one more rock we didn't talk about yet. So we have, I'll switch colors. No. Metamorphic rock. And don't be fooled, just because it kind of seems like it's at the surface. This is deep inside the ground as well. Does anyone know how we get metamorphic rock?
It sounds like metamorphosis, which means it's changing.
You're right, yeah. So it changes by applying heat or pressure or both. And I say that because sometimes it's a misconception that it's just, it has to be both, but sometimes if the rock is close enough to a hot pocket, it'll heat up and change.
I love hot pockets.
Or if there's lots of pressure, then it'll turn into metamorphic rock. Or if there's both, then it can change too. So characteristics that we have of metamorphic rock is that it's crystalline as well. And do you think that we could find layers in a different type of rock? Yeah, we could actually find it in metamorphic rock as well, which we call banding. But keep in mind that this is crystal in nature, and this is more grainy. So if you see layers that are crystalline, that will be metamorphic. But if you see grainy, compacted, that will be sedimentary. So we've talked about the different kind of rocks becoming each other. Can metamorphic rock become other types of rocks? So what are these both? These both undergo melting, right? So I asked, can metamorphic do that? Yeah. Be uplifted, turns into sedimentary. It can melt. Okay. And can metamorphic rock, once it's in the ground, can at a later time it be exposed to more heat or pressure and change again? Yeah, we're going to just draw it back going onto a cell. So, because I said that there's heat involved, does this mean that metamorphic rock is melting? No. So this, it's not melting. Melting only happens when it becomes igneous rock.
So what is it doing?
Oh, if it undergoes heat and pressure,
It just like
It-
presses it,
Yeah.
changes it. It doesn't actually like melt.
we think about the grains of crystals that we had talked about here. So we have them clumping together, and then it undergoes more pressure. What do you think is going to happen to those crystals?
Looks like
Yeah, they're going to get closer together. And we had heat and stuff. It's actually interesting because the crystals will separate and they'll kind of find their pairs and they'll elongate themselves together. And that's how we can have the banding structure that looks like layers, but it's actually crystals. So one last question, is this a one-way process, or can any rock become a different type of rock? Yeah, loops. Any rock can become any other kind of rock, that's good.